Hi, Year 8. This is your last lesson in this unit. This is pressure in liquids. So again, 3 questions start you off. How are particles in a gas arranged? What organelle in a plant contains DNA? And what is an element? Pause the video to answer those. Okay, so purple pen. Particles in a gas are randomly spaced and far apart. DNA is contained within the nucleus in a plant cell, and a substance made up of only one type of atom is an element. So in a liquid, how do they move? How are they arranged? How might pressure be caused in a liquid? Pause the video and answer these 3 questions, please. So you may remember from year 7 when we did particle theory that particles slide past each other in a liquid. They have a regular pattern with spaces and they're able to move freely. Particles gain more kinetic energy. More collisions happen between particles. Greater the depth, the more pressure from the weight of the particles above. So if we're talking about the sea, the deeper you go, the more water there is pushing down on the particles around you. So this is an investigation that we would do in class, but it's equally possible to do at home if that's where you are. So if you have a plastic bottle, pierce 3 holes in one side of the 2-litre bottle, cover the holes with your finger. So have them one towards the bottom, one halfway up, one near the top. Fill the bottle to the top with water. Release the water by removing your fingers. Observe and record what you see. And there's a YouTube video there and also on the Google form. If you are doing it on there, you can have a look at if you can't do the experiment. So what you would have seen is similar to the picture down at the bottom left of this page. So with the 3 holes, the top hole, the stream of water would have been nearest to the bottom of the bottle of water. Middle hole is the second nearest, and the bottom hole would have been going the furthest away from the side of the bottle. So have a go at completing this. Fill in the missing words. I'm there to help you in the keywords. Pause the video to do this now. Okay, so purple pen, your answers. The water flowed out from the bottom hole faster than the top hole. This is because the water pressure at the bottom of the bottle is greater than the pressure at the top of the bottle. The pressure in the water depends on the weight of the water above it. So this brings us on to density. The more volume and mass something has, the more dense it will become. How does density affect pressure? Think about floating and sinking. So the more volume and mass something has, the more dense it will become. What 2 ways will increase density? So these are the 2 ways. Keep the same mass and decrease the volume. So you're compressing it. Or keep the same volume and increase the mass. So you're adding more particles in. How do you think density affects an object when it's put into a liquid? So this comes to floating and sinking. If an object is more dense than water, it sinks. If an object is less dense than water, it floats. I'm sure you can think of examples of each of those. So some pictures here. We can see that the blue egg in the first picture is more dense than water, it's sunk. But in the second picture, it's been coated in bubble wrap and therefore is less dense than water and floats. So examples, metal and wood. We know that metal sinks in water, so it must be more dense than water, whereas wood is less dense and floats. So the amount of particles there are in the metal and water that occupies the space provided is a lot more than the amount of particles present in the oil and wood in the same amount of space. Water and metal are more dense. Okay, so we can see that wood floats on water and oil floats on water as well, whereas metal will sink. Okay, so your task for this lesson. The world is under attack from giant aliens from a parallel universe. The only hope is to go to the depths of the ocean with a nuclear bomb and destroy the opening between the universe. We need your knowledge of pressure to design the, I'm going to go with Jaeger robot to deliver the bomb. Okay, so we need to think about pressure. We need to deliver the bomb to the base of the ocean. So what will the water pressure be like at the bottom of the Mariana Trench? and think about why. Okay, so this is one of the deepest places on Earth. How can we get a bomb there without it being crushed by the weight of water above? So experts are trying to convince the commander that their Jaeger is the best design for the mission. The commander wants you to look at the designs and email him with your recommendation using knowledge of pressure in liquids. So we've got two here. We've got different raw materials. So think about the properties of aluminium versus steel. Different thicknesses, 1.5 meters to 0.75, and the head of the visor, head visor. The visor height on the left one is 5 meters, on the right is 1.5, width is 3, width is 1.5, and the thickness of the glass is 0.5 meters compared to 0.1 meters. Okay, so think about which one would be the best for surviving under extreme amounts of pressure. And this is what you need to do. You need to send your commander an email. So either write this in your book or complete it on the Google form if you're doing it on there. Recommending the best Jaeger design for the mission. To be successful, you must justify your recommendation using knowledge of particles and pressure in water. These are your keywords. So collisions, pressure, depth, density, weight, force, compression, water. This is your final task for this lesson, so you need to make sure that's written out clearly. We're expecting a paragraph of writing using those scientific words to explain your choice and justify it. Okay.